And the thing that Mac was missing was the invention of the magnetron. It came from some dark lab in England. The Rad Lab could play the game of a critical mass and enough people working in the same direction, but it could not nourish the diversity of a Lanchu and others over a long term.
Well, my criticism is the opposite of yours, Herb. That is of Project Mac.
It wasn't a criticism, John. I'm asking in hindsight, was there a different
I'm
way?
about to criticize.
Okay.
And that was that it abandoned too early the goal of a high performance computer utility time sharing system in favor of research in what in my opinion was esoterica, namely rings of protection and things of that kind. And
which was a necessary feature once you got us public utility.
No, I don't agree.
Well,
let me finish
let me at least get another word in it later.
Yeah, you'll get it. Now, in my opinion, this has led to a failure to solve a problem that has not been solved to this day. Namely, nobody knows what is the required for a high-performance time-sharing system. There are enormous gaps between what the computing that one can calculate is necessary to give service to users and the amount of computing that actual existing time-sharing systems do, so that their efficiency is their efficiencies as time-sharing systems is well below 0.1.
I find that
problem is
I don't understand.
Isn't that a moot problem now with all these microcomputers?
No, it's not a moot problem.
I don't understand your comment. But it seems to be.
You're saying that the whole notion of treating time sharing, the problem of time sharing, and finding a more generalized approach to it, and therefore arriving at the best way of doing it was ducked.
I still think
I'm not talking about generalizing. I think generalizing was probably the approach that was taken, and that was a mistake. You see, for example, every computer that is used time sharing today on any large scale is a computer that in fact was not designed for that purpose.
That's right.
And this is 20 years later. I regard this, I now have a student who has at least agreed to do a thesis, whether he'll do it or not,
how long was it taken to
subject.
build a machine that was designed to do your Lisp? I gather that this has just happened within the last year.
Not within
Maybe
the
you're too
last
impatient.
5 or something like that. And it's not even clear to me that was a good idea.
I just don't understand the comment.
Well, all right. Let me make a very specific comment. I remember coming to one of the meetings that was held, in '63 or something like that. It was at a time before Multics had been delivered. Maybe it was after '63.
That probably was 64.
It was before Multics had been delivered, but when things were pretty well understood. And
that was probably fall 64.
And the question came up, the subroutine linkage was being discussed.
You kept coming.
And I said, well, what's the subroutine linkage to do a square root? And I was told that was 32 microseconds. And I said, that's disgraceful that you spend that much time on a subroutine linkage. And of course, it took that much time because of the various forms of protection that were involved. And so I was very disappointed that it seemed to me that the Multics project, and you were even explicit about that when I criticized, had abandoned the goal of making a high-performance time-sharing system in the sense of efficiency in favor of being a research vehicle.
No, I object to that description. I think that's gross mislabeling. The objective was to try to understand what it took to develop the necessary isolation and mechanisms so that one could manage a multitude, a large community of people, not all of whom were in the same room, no matter what they might inadvertently attempt. Now, the subroutine linkage that you referred to was a consequence of several other objectives, one of which was to be able to share pure procedure. You're taking a very simplistic view of it and acting as though your time-shared computer has one user on it, namely John McCarthy.
That is as it should be, I think.
You've always minimized the complications of meeting other objectives.
Well, but let me make a comment on that. The winning time-sharing system in terms of market has not been Multics or any descendant thereof.
That's no fault of ours.
Well, but wait a minute. Yes, I believe it was.
I resent that.
Namely, it was that nobody today, in designing a time-sharing system, puts in that elaboration that you thought was necessary in the 60s.
They're all working back to it. You just haven't looked at those designs yet. They are working right back.
Computer is a growing industry.
Look, John,
The Unix system is having to be patched and patched and patched to put in the ideas that weren't there yet. Okay? They're backing into it. The thing that went wrong with Multics was we picked the wrong companies to work with. Big surprise. What did we do about it? You don't do anything.
No, I think you could have destroyed that.
you are quite right that the sort of thing that Multics did was never duplicated in any other system except to some extent in the Japanese system. And this is quite unfortunate because in the business world they've had a heck of a lot of problems with all sorts of monkey business done with computers, and there is nothing that they can do about it. That we know only probably a 1% of the trouble that they had, and this is the reason that there is no computer system that has even had the pretension of having protection of access.
But John's right on one point. I will at least.
And certainly this was a compromise that we made.
John's right on one point, and that namely that when in doubt, err on the side of simplicity.
Yeah.
And in some sense, that lesson's been learned over and over again. I think Herb's ventures were far too ambitious for the day, and my quick and dirty solution turned out to be much more effective. If I had to do Multics over again, I would definitely have simplified and streamlined some of the ideas. There's no question about that. It would have been a more effective solution, but not everything would be scuttled just in order to get there. Some of the ideas had in fact, almost every one of the ideas had some justification, so the question of streamlining is non-trivial.
How was the decision for the emphasis on security made? Who made it? What was the discussion process?
Well, let me start out that already in CTSS, there was a considerable emphasis on protection.
Well, that's because
along two directions. One was protection of files in the sense of backup. And that was largely, both of them really were Corby's push. Protection of files, and at that time people just did not believe that you had to back up files. It was a big fight in many instances. The other thing was the emphasis of controlling access. And now I think that originally the control of access was not in terms of resulting from concern about privacy as an abstract thing, but from concerns of accidental messing up of other people's program and
both. The background that I had on that was that I really believed the rhetoric of trying to work towards a utility.
Yeah.
Okay? If you're going to have a utility, you really must allow each user to control his own environment and his own objectives. And so that's where the access control came from. We already had some early versions of it in CTSS. It was kind of crude and heavy-handed, but it had to be. And we had a more refined version in Multics. But it was only from from the point of view of trying to let the user control the degree that he wanted to interact with other people, and also at the same time, obviously, to keep the machine, the debugging problem straight. But mostly it was a privacy version, which we felt were mandatory when you take the large, take a utility in the large. And in fact, most of the complaints I hear about contemporary systems are the lack of such features.
What was the process of
No,
design decision?
that's not.
The design decision was basically, I guess I'll take some of the influence, but I certainly would never have been able to carry it on unless there were other people that believed the same way.
Oh, yeah.
Did you have a committee? Did you debate these issues?
Well, wait a minute. It came in two stages. CTSS was developed within a small, by my group of 3 or 4 or 5 people. Okay. That basically was just done by our own intuition, largely based on the discussions that went on the committees, this long-range computation committee that had been building up steam.
See, who were the people in that group?
Which group?
The CTSS group.
Well, Marjorie Merwin, later Daggett, was my key co-worker, and Bob Daly was the other key well, there are 2 key
Dick
ones.
Steinberg was in there too, wasn't he?
Steinberg he was running the computation center as an assistant director, but he didn't contribute directly at the programming end. Bob Creasy, and there were a few other names. A handful at first. Most of the others were doing minor things like working out a command or 2 or something. But the general design stratagem of keeping users from meddling in each other's work was basically on the intuition based from having had, well, I guess the key ingredient there was I had management responsibility at that point for running the computation center. Anybody that runs a computation center is aware of the need to protect the interests of the users of that center. So that was a key background piece to it. John is basically accusing us of having been preoccupied with it, I think.
Well, I have no quarrel with CTSS in that respect. I mean, maybe I would if I understood it better, but I don't. My quarrel was with Multics, not with CTSS.
Well, Multics...
It's an extension.
It's an extension. The amount of overhead in that aspect is not excessive today in Multics.
How much time does it take to link to a subroutine?
Jesus.
John, look, we basically wanted to create a stack environment which allowed pure procedures, which allowed segmentation, and with all of those goals simultaneously, you do arrive at a certain amount of overhead. It turns out that the protection aspects that you've seen, the ring aspect, which was built into hardware late on the second round of equipment, and has certainly been pulled out and down into the insignificant area. And that machine is not inefficient today. It's just undersold. Okay, it's undersold because the prices are way too high.
John, do you have your own big personal computer now?
No.
I've had my own for the last 10 years. My own little PDP-15 that I now have 1 million words of memory on, and every damn graphical input, output, the thing that I want. And I'm happy as a damn clam. I don't have to keep a public utility happy. There's only one trouble. If something goes wrong, there's only one guy to blame, me.
Yeah, that's unfortunate.
No, Corby said that the main thing that people quarrel with about time-sharing systems is lack of protection. And I have, managed many computers, or several computers anyway, and I've never heard that as the quarrel. The quarrel that I have heard continuously is lack of capacity. And
You've always operated clubhouse computers.
no, I didn't. I operated a computer with 4,000 users.
Yeah, but John,
That's not a
There's
clubhouse.
Parkinson's
There was
law.
enough protection then so that people didn't get in each other's way.
Well, but you see, let me make the following point about that. The machine that we were using, this is the low overhead time-sharing system at Stanford, which is used for student computing.
Yeah.
It has 4,000 users. Now it has 2 DEC 20s. When I started it, we had 1 DEC 20.
Yeah.
Now, there has been no serious complaint about lack of protection, but there has been a continual complaint about lack of performance. And the dominant computer today in time sharing is the DEC 20. It probably won't stay that way. And it doesn't have segmentation. And as far as I can see, segmentation is an idea of the past.
But John, look,
No, that's not true.
what you're fighting is Parkinson's law. Usage will grow to fill and exceed
That's
capacity.
right.
No, that's not
Has
true.
always been the
You're
case.
criticizing.
No, that
you're
isn't true,
critici-
because there are other computers at Stanford which have DEC 20s, but have limited populations for which the complaint, for which there is no serious complaint of lack of capacity.
The operative word was limited population.
You're criticizing every machine that isn't basically in the largest commercial sale category, and that's not fair, because in fact, the DEC 20 doesn't meet all environment requirements. It meets some, and it meets a kind of a core around student use in a rather homogeneous population, trying to
No,
apply
not
it.
merely student use. Stanford has approximately
Homogeneous.
10 DEC
Leave
20s.
out the student. We have a lot too, but they don't meet all our needs.
Let me inject something, because I think there is some misunderstanding here. If you look at Multics as an attempt to provide a time-sharing system for MIT, you're quite right. In other words, that a different system would have been better as a time-sharing system for MIT. If you look at Multics as an attempt to develop a utility concept in time-sharing system for any organization, then you're wrong. It depends on what you're intending to do.
Well, who uses Multics as a computer utility?
Oh, my God! Most of the places are not universities.
There are about a dozen. There are about between a half dozen and a dozen universities in Europe that have.
Well, but there are
And-
there are
about
lots of-
1,000 DEC 20s.
Of course, I didn't
course.
say it's a marketing success.
No, it
You're
is.
going back into marketing mode.
But if the marketing success, depends on a lot of things. First of all, you want the manufacturer to do marketing, and Honeywell, after General Electric, never marketed.
DEC had a great reputation for marketing, and the reputation was if you really tried about 5 times, you could get them to return a phone call.
Let me ask a question. I've been out of the computer game for the last 10 years. Recently, I got a fairly big contract from IBM on a project. Forget it. But I had a chance to use their time-shared system that's tied in with their Yorktown Heights computer from Cambridge, and it was god-awful.
Yeah.
I mean, it was like I was back to punching cards again. And here I've been used to getting miles of graphics with lovely curves, and I couldn't do it. Now, whose fault is that?
That's IBM's fault.
They get stuck.
Partly it's MIT's fault too.
You're going to blame us for that too?
No.
Sure, right. I'll blame MIT for it in
Hey.
the following respect. I believe that in TSS, IBM followed MIT into the swamp.
Look,
Only they realized that it was a swamp sooner than MIT was and abandoned the project.
John, that's
mean, John.
that's me. Come on. Hey,
Oh, well, look, I've said this to so many audiences, I should say it to you.
John, look,
can we back off?
what you're saying in the discussion now echoes in my ears, because we're exactly the discussion that were taking place at the technical committee that you mentioned. And basically there were a few people, mostly Marvin Minsky and the I group, who were terribly impatient at anything that CTSS had that in any way reduced the speed of computation for their purposes. This is basically what it was. And for instance, they objected to all sorts of protection, even CTSS, because in one way or another, much or less, they were objecting. That is, they were not interested in the notion of a community utility, which is instead the notion that was driving Project Mac. This is basically difference in objective. Neither one is right or wrong.
In fact,
They were just two different objectives that were clashing.
But if you take those
fact,
who do produce a community utility, like Source or and so forth, which have very large numbers of users, of commercial
Oh, yeah,
users,
but this is not-
they use DEC machines. They didn't even consider
Yeah, but
using
you
them.
see,
but your software
that's not-
interfaces
that's
don't
not-
allow you to do any
That's not.
arbitrary program.
It doesn't allow
John,
you to do. That's just a file server.
John,
But
let me
look,
ask a question
let-
about
can
your
I-
DEC 20 system. How good is it on getting miles of graphical output?
Just fair, not very good.
Not very
Look,
good.
I mean,
And the
it's-
second half is down all the time.
What?
It's down all the time.
No,
Yeah,
no, it's
but don't knock it. I mean, look, we use a
It's
deck.
pretty good. I mean, it
DEC 20
serves
is
a
a-
purpose, but it's a different thing.
Well, maybe we should merely record the fact, or it has been adequately recorded, that we are in disagreement on these issues.
Yeah,
and
but
not
for
try to
instance,
resolve them at the moment.
I would never put the final examination on a DEC 20. I would never do that.
It's a good workhorse, but
You know?
it's not.
It's just
the-
not safe.
Look,
But
No
well,
personal letter
a
that-
smart student could tap into your system even today.
Multics is the hardest.
Is
He'd have to work at it.
really
You might want to
work.
give him his
No.
degree when he did it.
Well,
but it
Well,
could be
I
done.
remember the early times
Well,
in which Multics people, because of the fact that they were slow in establishing 30 character per second ports on Multics, used to go into Multics through ITS, and someone on ITS made a password trap.
All sorts of things.
yeah.
Yeah,
Well, that's part of the sociology of
in,
illegal behavior.
when you're talking about the protection, there are all sorts of levels. The point is that you want a level that is reasonable for the particular purposes. Now, I think that the DEC 20 is not adequate for many common purposes around MIT. Multics is adequate around MIT. Of course, any real expert that is willing to put a lot of effort probably can break Multics. In fact, it has been broken at a certain point by a team of experts. So, it's where your goal is.
But there's another problem, though, with all of the time-sharing systems, including the DEC 20, and that is that they have achieved sort of a dinosaur-like qualities, where they're too big, too complicated, and for easy maintenance. And at least in a sense it is, if you have to influence the manufacturer to make the changes, you have a long path to get a change in.
Which is
And-
par for the course for a
which is-
utility, though,
Which
right?
is par for the course for utility.
Yeah.
And so that's why people are turning more and more to the autonomous, high-powered workstations,
Yeah.
where they can get the performance and the interfaces that they want.
Well, I think that you find people trying to harass the manufacturers on those too.
Well, of
Because the
course.
thing has gotten too complicated, and while in principle they could change it themselves,
Well,
in fact they can't.
Talk is cheap.
Well, the biggest
But look-
computer used today, though, still is video games, right?
I suppose.
And it's adequate for that.
It seems to me, Phil has said he had to leave earlier, and it seems to me useful if we could get into this, get through this one crucial part of Mac's history, namely the way we acquired a second, or the next round of machine, namely Multics, which have turned out to be Multics, and the corresponding repercussions with the various other vendors, because
I've got one point that's still earlier that I'd like to
all
get
right.
over with,
Okay.
and that has to do with Strachey.
All right.
Now, you guys put in your Scientific American article
Yeah,
a
you've been
statement
great.
that it was
I know.
Strachey's idea,
And we were wrong.
and then you corrected it.
Yeah.
And you said, well, Strachey had the idea simultaneously.
No.
And that isn't true either.
No, we didn't say that. And very unfortunately, the Scientific American never corrected things as I had requested. They put it a note someplace that was hardly visible, and when they published the book, in spite of my request, they never made the correction, so that in the book it's still just like the original. But the point is that Corby and I were unaware of your memorandum when we wrote the thing, and we found out only when you wrote to me pointing that out, and when I read the memorandum, Corby dug it out of the file, there was absolutely no question that your discussion of time sharing that memorandum had priority. There was no question.
Well, I think.
Well, but you see, it wasn't merely
No,
a question of priority.
No, I
Yeah.
understand.
It was a question that Strachey's idea was different. Now, that is partly my fault,
Yeah.
because in my 1961 lecture, I referred to Strachey's paper.
Yeah.
Because the state paper was entitled Time Sharing Large Fast Computers.
Yeah.
And I took the view, who could mean anything different by that than what I meant by it?
Yeah, okay.
And I skimmed Strachey's paper very superficially,
Yeah.
and I felt an obligation to refer to this prior publication. And, anyway, Knuth, I harangued Knuth on this point once.
Yeah.
Knuth wrote to Strachey and got a letter back in reply in which basically he said, the paper I wrote called Time Sharing in Large Fast Computers was read at the first pre-IFIP conference at Paris in 1960. It was mainly about multi-programming to avoid waiting for peripherals, although it did envisage this going on at the same time as a programmer was debugging his program at a console. I did not envisage the sort of console system which is now so confusingly called time sharing.
Yeah.
I still think my use of the term is the more natural.
Well,
Okay, that's about all.
yeah,
that's-
no, it's nice to have that intent cleared up. And
Yes.
I've reviewed that paper, and from the paper, it's somewhat ambiguous how many terminals he had in mind, although it also seems fairly obvious that he was thinking of one.
He was thinking.
Namely the ability to debug. He talks it in the plural, but he had in mind an operator. He then begins to itemize what he had in mind. And it was an operator's console and the programmer's terminal. And, he had a very limited view of what he was trying to do. Mostly he was trying to do was to combine interactive computing with a background job or a batch job going on beside it without losing efficiency of the machine.
Well, he wasn't much interested. He says, don't place too much reliance on Halsbury's accuracy. He tends to rely on memory and get the details wrong. But he was certainly right to say that in 1960, time sharing as a phrase was much in the air. It was, however, generally used in my sense rather than in John McCarthy's sense of a CTS-like object, CTSS-like object. And
Wait a minute, that
he
wasn't
was
your
ri-
sense either, though, John.
What?
That wasn't
No,
your
my
sense
sense is
either.
essentially that of a CTSS.
A multi-terminal
Multi-terminal
system,
system.
where the terminals are acting independently in the
On which
Yeah.
you could do Lisp.
Yeah.
one
Well,
of them.
but you see, that's a sort of an interesting point, because my idea was always for an arbitrary language time-sharing system. The first one-language time-sharing system was, in fact, the basic system.
That's right.
No, JAWS, wasn't it?
Josh.
Yeah,
Josh,
Josh was
right.
before, yeah.
Yeah, right.
But,
To complete that explanation, I think you are right, John, that you were partly responsible for my being misled, because my knowledge of the past depended considerably on your article. And since there you didn't mention any paper by you, but that emphasized Strachey, I just went by it.
Well,
But there is no question that the first technical particular, because look, I had people write to me and talk to me about all sorts of priority time sharing systems.
that was the interesting thing.
That was the entity. For instance, from a certain point of view, SAGE was a time sharing system. Lots of other were. The important thing that was really made a difference in whether there were several users who could do totally independent thing on that system. That really was the thing. And as far as I know, the tools for doing that from a technical standpoint came out from your paper. That's basically it. And the first person that was concerned about the boundary registers, which is essential to doing that sort of thing, was in your paper.
Yeah,
No,
and-
that's not true. You see, Stretch had boundary registers.
No, I don't mean
Why
the
they
boundary
had boundary registers is obscure to me.
This is the point. In other words, that you made the case for what it was
wait a minute.
necessary. You
No,
made the
it-
case for what
No,
was
but there was,
necessary to
there
make
was a
it
lot of
consistent.
confusion on this point. In fact, I can-
Now, let me make a point. I understand now why Stretch had boundary registers. This is sort of interesting. Namely, Ted Codd had this idea of an operating system for Stretch, which would optimize use of the machine by combining jobs that had different requirements for memory use, computation, and input-output into a kind of optimal package of fitted together rectangles. He had this picture of fitted together rectangles.
You didn't need boundary registers. That you need relocation registers.
No, well, he needed both, but you needed boundary registers because you could imagine that these jobs were undebugged, but they were being. But what he imagined, what Codd's idea was a batch system that fitted together the jobs in an optimal way.
Right.
And for that, he needed, I guess he needed both boundary and relocation.
Both, if you're going to do that.
And he had it on stretch. The actual history of that thing is that it was implemented, gave an improvement about 20%, and therefore was never used because it had other disadvantages. And anyway, all the people who used stretch were very pig-headed and did their own operating systems anyway.
That's an exotic footnote. But one of the things that I recall, there was a lot of confusion in that era about what time sharing meant, and what we kept meaning was general purpose time sharing, where you could write, any arbitrary user could write an arbitrary program.
This is the
And I can still recall that was one of the places where IBM's management kind of lost sight of the issues. We, in fact, discovered in the process of trying to acquire the next round of Project Mac machine that at least Manny Piori thought that their work on the American Airlines Sabre system, reservation system, which they were deeply involved in for around 59, 60, was in fact equivalent to a time-sharing system.
That's right. There was
so he thought that they had all of the experience and learning that they needed out of that.
Basically, when we started Project Mac, I sent one of the proposals to Manny Piori, and I really didn't get any positive reaction from it. He somewhat say, well, nice, almighty. He just missed the point. And when at a certain point, I went there to talk with them because we were not getting anywhere with an IBM proposal. They were proposing Pitlin thing, a small 360 that was totally inadequate and so forth. It became quite evident that he had missed totally the point. And he thought that the Sabre system was a time-sharing system and there was nothing additional that we were suggesting.
Well, you're right about that. That's interesting because that point of view explicitly showed up in an IBM advertisement around that period of the time, in which it said IBM's experience in Sabre and QuickTran, which was a one-language time-sharing system doing Fortran, makes IBM the leader in time-sharing.
Yeah, that's
and I remember I was amazed and annoyed by that advertisement of the early days, but that was really their point of view.
There is a point I think here that though it should be made. I remember at the time when I was talking to John about boundary registers and memory protection and whatnot, that he and I looked on these slightly differently. As an engineer, I looked at them as one possible solution to a particular problem. And John thought they were more fundamental than that. And it could well be that the IBM engineers and you did not communicate. Because, who gives a damn, a boundary register? The guy thinks in terms of a bunch of flip-flops and a comparator, and he's got it.
Well,
it's not that hard to build.
Well, I mean,
and it's not that hard to conceptualize.
Well, let me make a remark about that.
Yeah.
Because when you proposed boundary registers and relocation registers for the 7090, I had thought of these things, but I said, they'll never do it. Because I had completely wrong ideas about how difficult these things were, how much they would slow down the performance of the computer. In other words, I said to you, but to take the extra time to do an additional add at every memory cycle will slow down the machine too much. And you said it wouldn't. And I was very surprised when IBM agreed to do what you what you had written, and I was still further surprised when not only did they do it, but it didn't slow down the machine.
No, because whenever you give a command to memory, you gotta sit there and wait in
And
it.
wait,
They
anyway.
tucked it into the idle time, sure.
That is basically what your memorandum showed is the concern for keeping various processes of different users separate. In other words, really the separation of what the user were there and making sure that they didn't interfere. And this was critical. That was the critical technical point. Now, of course, there are always different ways technically to solve the problem. But that memorandum showed an understanding that there was a problem that had to be solved, and you proposed a solution. Now, there are other ways of doing it, of course.
Well, my memorandum was pessimistic about being able to solve it in hardware, as in fact it was eventually solved, and proposed various rather complicated software solutions, which fortunately were not required.
Yeah.
Well, the thing that I still recall with some shock was when we first began to get wind of the IBM 360, what came to be known as the 360. Several of us were given a kind of advanced, we signed proprietary agreements, non-disclosures, and were allowed to read
We
the
were
instruction
flown
manual.
to Poughkeepsie.
Yeah, and the thing that was kind of, the first warning that all was not well was that the whole damn manual was in capital letters. Printed on a line printer and really rough to read. And the second warning was that when we began to realize that, belatedly, that Gene Amdahl had probably dominated the design. It wasn't clear who dominated it, but
Yeah, he dominated it.
but
It wasn't clear whether it'd be a success, so they weren't lined up to take credit.
yeah, right.
Let's see,
he-
you have the, do you have that management of the computer book?
It was here.
It was
Yeah,
here.
it was here. I don't know
Floated
who took
around.
it. It was sitting
Yeah.
there. But the thing that was, I still remember, as if it were today, sitting next to Corby at that meeting, and he suddenly hit, not just, well, I don't say that physically hit the ceiling, but I could see him jumping up when he heard that the 360 had a write protect and no read protect
Yeah, you could read any part of memory anytime.
anytime.
So
I can still see that's
Now, it's interesting to see, I'd like to read a little bit of Amdahl's commentary. Amdahl had an extensive commentary on my paper.
yeah.
this is when?
61.
61.
So this
okay.
was while he was in the middle of things.
Early design stages.
Yeah.
Right. He says, I'm with Dr. Mockley in being primarily in agreement with Professor McCarthy. I do have some reservations about whether every individual user will desire to operate his own console.
That's
Not everyone wishes to operate his own typewriter. For example, I feel that before it will win common acceptance, the language employed for communication between user and computer will have to become much more universal and efficient, yet be redundant enough to permit varied problem formulation. Well, I believe that the typewriter console should have larger character fonts to permit ready expression within this language. Some inventions in the areas of keyboard and print mechanisms to permit character font expansion economically and reliably would be very welcome for computer consoles. So you look at that and you say, well, he was advocating some things that he did not do, but he was rather confused about.
Well, no, he
Jim
used,
Andel definitely designed that machine for batch processing. There
he
was
had,
no question
in fact,
said
he admitted it later.
he said so.
No, he said so at the time.
Yeah.
Yeah.
I asked him when we visited, do you expect that he was talking about, well, it can do time sharing. Do you expect that time sharing will be the main way in which the computer will be used? No, the main way in which the computer will be used will be something like the Bell Labs operating system
Right, which is a batch
what he
system.
explicitly
He and
says.
Fred Brooks either did not design it for time sharing use. As a matter of fact, they did the opposite.
Well, they didn't deliberately not design
No,
it. They
but
just didn't. They
They
just
wanted
didn't.
to get
just
together
totally
two
disregarded
strains,
that.
the 705 strain and
Yeah,
the 704
they
strain,
disregarded
under
that.
one umbrella.
As a matter of fact, when we decided to go with the G equipment, there was again the research lab of IBM got involved, and they came up to see us, and I know later on, what's his name? The IBM that was big and big fellow.
Poe Evans?
No. The research laboratory. Oh, suddenly the name.
Jack Bertram?
Huh?
Jack Bertram?
Yeah. He said it to me later on. He said, look, it was terrible when we came up because clearly we didn't have what you wanted.
Well, what happened was at one point or another, at the time when it was too late, Watson Jr. said to them, I don't care what you think of what MIT wants, give them what they want.
Yeah.
Let me recreate that period, because
They
I
made a
think that it was a fairly
When did
tricky...
he say that, John?
Yeah.
What?
When did he say that?
Well, just before MIT
As
made
the
its
vote
final
was sitting?
decision. Or maybe slightly after MIT
Yeah,
made its
that's
final
right.
decision. to
No,
go
the
with
chronology I remember goes this way. IBM showed us their design of the 360. We began to criticize it, first orally, later in a memo or so, pointing out all the complications of the addressing, of the memory protect schemes, the fact that it didn't tolerate...
And the channel.
It didn't have...
Channel was a big
Channels were mixed up. Multiprocessing wasn't supported.
Yeah, that's right.
And paging wasn't supported. So a lot of complications were showing up. We tried to get these reflected back to the designers, and it became clear that we weren't getting the attention of the Amdals and Blaus and Brooks. And in fact, we were kind of being shoved to a side, and they were viewing us as whatever needs to be done will be done, but it'll be kind of an expensive kludge, and we'll do a one-of-a-kind for you guys just to keep you happy. So we, meanwhile, we're talking to people like DEC, and DEC was strained pretty badly. It was a smaller company then, and they weren't really able to be very responsive. And as Bob said, kind of in midstream, we got wind of the GE people, and it turns out, due to the individuals involved, John Weil and John Kalur in particular, who were then and this is a computer department of GE. It wasn't a division even. So we were a little naive in that sense, and that's down pretty far in the totem pole of GE. But we began to work with them, and they were very eager to change their machine to match our requirements.
Let me interrupt you a second. To start with, the basic architecture that I had was the architecture of a military computer that I developed. That, for reason of the objective there, was very much communication oriented. You see, it was basically communication oriented in the sense that all the components communicate directly to the memory, not with one another. And we saw that as a tremendous advantage for our purposes. And we hit it very well from the point of view of general architecture with Weil and Kalua at the first meeting that we had, I recall. And they saw our point of view, and we saw theirs, and it moved very fast. When finally the proposal came in, the ranking by the technical committee was evaluated was GE first, Tech second, and IBM last.
Yeah. Well, the GE people were responsive to all of our notions of memory management, and that's where segmentation, which Jack Dennis actually had proposed, was embeddable, and along with paging and the multiprocessor configuration. The thing that another aspect of it was that IBM, to some extent, thought they had us in the bag. Because they really thought their competition was DEC. They had no idea that it was GE.
Yeah. When I went to see Manny Fiore the last time, and I said him, I was getting kind of impatient with IBM, and essentially I told him, I don't remember the words, but I said, look, IBM is not the only computer manufacturer that we are talking about. And clearly, he thought that the competition was DEC, and he didn't give a damn about DEC.
Well,
he didn't really worry about it.
Let me read something
When
else.
he found out that it was GE.
Well, let me pick you up in a moment. What happened was that when they found out, they got very agitated, and because IBM made the mistake of thinking that GE was a formidable
That's
company because of its giant financial base.
Yeah.
What they didn't recognize is that GE had almost no representation of computer technology within the top management, and as a result, their management
We made the same mistake.
Yeah, their management was very narrow. And in fact, we were talking to the most competent computer people, and we had their ear, but they weren't the top of the heap.
But the
Well, let
problem
me
is,
make a couple of remark about the GE technical people. The GE technical people in the computer department had been users of the IBM 704. And basically, when they got the opportunity to design a new machine, they said, think of all the things that we would have liked to have on the 704 and put them in.
Some of
And
it,
so the machine came out as a kind of jazzed up 704. But let me read this remark by Amdahl, which shows that he knew a few things that he, however, didn't get. I have some final remarks to make relative to the requirements of the time-sharing and multiprocessing concept favored by Professor McCarthy. In the requirement for relocatability, he suggests that when a program ceases to be active, it leaves an odd-shaped hole in memory. He suggests that it must be possible to move other programs down to fill this hole so as to leave a contiguous block of space for new programs and data. It is possible to generalize relocation more completely so that such program and data transfers need not be performed. Rather, the new program and associated data can be fitted into a selection of available odd-sized holes and be processed from this non-contiguous storage. Incidentally, the same feature could provide memory protection automatically. The newly announced Burroughs D5000 has this capability if I interpret its description properly. In such a time-sharing computer, progression through a large number of users' programs would soon make memory allocation look like an unplanned patchwork quilt. It would appear, however, completely orderly to each and every active program. So he had paging rather solidly in mind at that time.
He had paging in, but not. But I asked him about it several years later, and he never thought of interrupting a program, taking it out of memory, and bringing it back to a different location. He thought of running each job to completion.
That's basically his point
So he
of
could
view.
bring it into an oddball set of locations, but he couldn't take it out and remap it.
Well, but now he had everything in the 360 for interrupting a job.
But only to
so
bring
if you
back
put
to
the-
the same location.
Well, that was, now my
Because his
understanding of
addresses
what he
got
says
bound
here.
into the addresses got bound into the address space of the procedure.
My impression of what he says here